question 3. So we've got a fairly complicated situation. This is a triangle, obviously. It's isosceles, 17 down the left, 17 down the right. Across the bottom it's 30. M is a midpoint. It's halfway across from C to D. With center... using M as a center, we now make this a diameter, and we get a circle, which would be this one is half the circle. If you went all the way around, that'd be the full circle. And with center O, we now go around like this. That would be the full circle. So this is just a part of that circle. It's an arc. And R is the region bounded between them. Okay, well, let's just get our heads in gear by doing a bit of Dear Mr. Examiner on this. I'm going to work out the distance from O to M just with a bit of Pythagoras. Be amazed if that wasn't useful somehow, and it's very quick. I'm going to call that X. So x squared plus 15 squared equals 17 squared. X squared plus 225 equals 289. X squared therefore equals square root of 64. Gee, that come out nice. Therefore x equals 8. So I don't need x anymore. I can just treat that as an 8. So basically I've discovered that is an 8 there. Now what I'm going to do is name this that's not very neat. So that's 8. That's 17. That's 17. That's 15. That's 15. And now if I press on down to this part, so I'm going to call that x, and I'm going to call this extra little journey all the way to the bottom of the diagram. I'm going to call that, this is very sloppy, sorry, I'm going to call that y. This is where pencils are definitely better. Okay, so I've got some names. I'm now going to state some facts. So I'm going to say area, sector, center, O. That's this one there. That's going to be 17. That's going to be half 17 squared 8 plus x. And I'm also going to work out the area of this semicircle. Area, semicircle, center, M. That's going to be half of a full circle. The full circle would have pi r squared. The radius is 15. I think. Yep. Okay, so me working those things out is just to get my head into gear. But what I'm really interested in is this polka dotted area. But I'll come back to that when I just have a check to see whether I've actually covered parts A and B. So the area of the triangle OCD. Okay, I better do that. That's nice and simple. Area triangle OCD is just half the base times the height. So that's 15 times 17. Oh, sorry, not 15 times 17. 15 times 8, which is 120. Now, so that's part A. Part B is the angle COD in radians. Okay, well, here I'm going to use the principle that two different ways to work out the same thing have to give the same answer. The area of a triangle is half AB sine C. So we already know that the area is going to come out to be 120. So 120 equals half 17 squared theta. So therefore 240 equals 17 squared theta. So theta equals 240 over 289.